Hey there, stranger, and welcome to the third video in our statistical reasoning series, normal distribution and the normal curve. Okay, so a little about normal distribution. A data set is said to be normally distributed when the mean, mode, and median are the same. That means it's going to be symmetrical about the mean, which means that half the data is below the mean or average and half the data is above the average. A data set that is normally distributed has a symmetric bell shape when graphed as a frequency polygon or histogram. So a frequency polygon, don't really worry about. A histogram, simply a bar graph, everybody. The normal distribution curve is very predictable and therefore handy to work with. We'll practice working with a normal distribution curve. So that's what we're doing in this lesson. Now, some properties of this normal curve, also referred to as the bell curve, everyone. So you may have heard of that. And what a bell curve kind of looks like this. Sorry, my pen kind of took a hiccup there, but it's called a bell curve because people felt that it looked kind of like a bell. Okay, ding dong. Anyway, the first property, it's unimodal, meaning there's only one mode, so there'll be no ties, just one mode. It's symmetrical, so that's why my picture's so bad here, is that really my left side is supposed to be equal to my right side. So let's try to draw that one more time. That looks a little bit better. Third, it's bell-shaped, like we just talked about. Now, it's bell-shaped, which means the highest part's in the middle, and that's because the mode, the mean, and the median, they're all there. And that's what my fourth one is saying. The fifth, it's asymptotic, which means the curve goes on forever. So the further the curve goes from the mean, the closer it gets to the x-axis, but the curve never touches the x-axis. So this red line I drew up here is never going to actually hit the x-axis, just going to come infinitely close to it. Area under the normal curve. And again, once again, here's my normal curve. Well, that's a decent attempt at one. In the middle here is always our average, okay? So 68% of our subjects fall within one standard deviation of this average. So, sorry, if I go my average plus one standard deviation, or my average minus one standard deviation, that's going to account for 68%, right? So that's going to be 34% on this side and 34% on this side. That's my 68%. Now, 95% of our subjects fall within two standard deviations. So allow me to draw that. So I'm going to add two standard deviations from the mean. And then I'm going to subtract two standard deviations from the mean. Now, what that is, let me pick a color. Purple. What a beautiful color. So that's going to be 95%. That goes out to here and here. So we're going to get our 34%, and then we're going to add 13.5 to that 34. Okay, so if I go 13.5 plus 34 plus 34 plus 13.5, I will get to the 95. And I have already realized that, yes, I've mismanaged my space, everyone, but we're just not going to worry about that. I need my red marker again. Now, if I take my average and I add 3 standard deviations, or if I subtract 3 standard deviations from my average, let's pick a new color here. It says here that 99.7% of our subjects fall within 3 standard deviations. So let's just, I'll just have to go above and beyond, people. 99.7%. And that's going to hopefully kind of line up with what I just drew. And then what that means is that in that little area, that's going to be 2.35% of your data would fall in just that area right there. Oops. And then this final area, what have I not used? Oh, I've used green, yellow. 0.15%. I guess I can fit that in. About 0.15% is left over, and then we can break that 0.15% up more as we add more standard deviations, which we're not. We're just going to go to 3 standard deviations above and below. But that's how that chart kind of breaks down. Now, that likely doesn't make much sense to you still, so let's just actually get doing some examples. So it says create a normal distribution curve for the following data, and then I got these 3 questions. Sorry about that. Let's do the first one. A mean of 145 and a standard deviation of 12. Okay, so first thing we'll do, we'll give ourselves a little bell curve. Mine, that's pretty flat. I really should have more of a kind of hump there, but that's okay. So your mean is the first thing you want to write down, and you get 145. And then what we're going to do is we're going to go 3 standard deviations above and 3 standard deviations below. And then now to come up with the numbers that work with those tick marks, we simply have to add 12 or subtract 12. So if I add 12 to 145, I get 157. If I add 12 again, I get 169. And add it one more time, I get 181. And then what I know is I know that 34% of the data in this data set would land between 145 and 157. I know that another 13.5% would land between 157 and 169. I know that I wasn't sure if I was going to fit this in. I know that 2.35% of my data would fit between 169 and 181, and I know that only 0.15% of my data would be above 181. So that's the right side. Now I have to go to the left side. So now I just start subtracting 12, so I get 133, 121, 109, and I'd have the same situation. I won't go through saying everything I said before, but I'd have these same percentages in these spots, and that's something I likely didn't stress enough, is that with this bell curve, with the normal curve, these percentages never change. All right, so that's why this thing's so predictable. It's always the same bell curve. What we change is the mean and then the standard deviation, okay? But those percentages will never change. Okay, for B, a little bit better bell curve. My highest point, though, should be in the middle, and I want to put that in the middle of my line, so really, it's not a great looking bell curve. But anyway, I want to have 16.3 here, and then like I said, 1, 2, 3 standard deviations above, 1, 2, 3 standard deviations below we're going to go. We're just going to start adding 9 to it. So if I start at 16.3 and I add 9, I'd get 25.3. Add 9 again, I'd get 34.3. Add 9 one more time, 43.3. Okay, and then I'd get all those same percentages. 34, 13.5, 2.35, 0.15. All right, now I have to start subtracting 9. So I'd get 7.3. I get negative 1.7 if I subtract 9 again, and subtract 9 one more time, negative 10.7. And again, I'd get the exact same percentages that land here. I would know that 13.5% of my data would land between negative 1.7 and 7.3. And maybe seeing there's negatives we're talking about, maybe that's like a temperature or something in a certain situation. 2.35, 0.15. Okay, final one. That's a bit better bell curve. Practice makes perfect, everybody. Okay, my average is 46, and now I just have to start adding. Now it's not a whole number this time, but I'm going to be adding 3.6. So 49.6, 53.2, 56.8. I mean, this is just grabbing your calculator well, really you don't need your calculator, but if you want to work fast, I guess you can use your calculator. 42.4, 38.8, and then 35.2. Okay, and I have all the same percentages. 34, 34, 13.5, 13.5, 2.35, 2.35, and then 0.15 and 0.15. So that part didn't change, right? Doesn't matter what question I worked with, it didn't change. Part B, now let's actually start doing something with this bell curve. It says, suppose the mass of northern pike in Canada Lake is normally distributed with a mean of 3.5 kilograms and a standard deviation of 0.6 kilograms. What percentage of fish in the lake have a mass of? And then there's all these questions. Normally distributed meaning the mean, the mode, the median are all the same. Okay, which leads us to a bell curve, because then it's normally distributed. Okay, just kind of piece that together for you. So what we need, if it's normally distributed, let's draw out this bell curve, and then we should be able to answer A, B, C, D, all that kind of stuff. Okay, there's my bell curve. So it says a mean of 3.5. Standard deviation of 0.6. So 1, 2, 3. We'll go 3 above, 1, 2, 3 below. So that'd be 4.1, 4.7, 5.3, 2.9, 2.3, 1.7. And I'm sure you're getting tired of this, but we're going to write these percentages down. 0.15, 2.35, 13.5, 34. And why? Well, you'll see here in a minute. 34, 13.5, 2.35, 0.15. Okay, now based on this bell curve, we can predict what we think, or the percentage of fish in the lake that would have this mass. So we're looking for the percentage of fish that have a mass more than 4.1 kilograms. Okay, so here's 4.1 kilograms, everybody. We're wondering how many fish have a percentage or a mass higher than that. Well, then I just simply add them up. Okay, so I'd add 13.5, 2.35, and 0.15. Which works out to 16%. Okay, so I was really, and I know this is going to maybe not be great for me because I got to keep using it, but I just added these 3 regions. Okay, everyone? Now I'm looking for more than 4.7, so let's get a different color. More than 4.7, well, that means then I'll add just those 2 regions. So 2.35 plus 0.15, 2.5%. So we're thinking that about 2.5% of the fish will have a weight more than 4.7 kilograms. Okay, how about less than 1.7 kilograms? Well, there's 1.7. Less than that means we're going this way, so I'm just really worrying about that guy. So 0.15% of fish will be less than 1.7, so a very small amount. D. Okay, what percentage of fish will be between 2.9 and 4.1? 2.9 is right here. 4.1 is right here. So what we do is we just simply add the regions between. So 34 plus 34, so we know that's going to be 68%. And the final one, where's the color? I'm going to use purple. 2.3, so 2.3 and 3.5, which is right here. So then we'll just add these 2 regions. So 13.5 plus 34. So 47.5%. All right, so that's how we can use this bell curve to determine what percentage of fish, in this case, kind of fit these requirements. Now, if I knew how many fish were in the lake, I can then multiply that population by these percentages, and you get an estimate for how many actual fish would be between 2.3 kilograms and 3.5. So let's do that in this question. So the first thing I'm going to have to do, and I'm sorry that I have to do it again, is I'm going to draw our bell curve just so we can have something to look at. I'll try to draw it kind of fast. Again, I'm not great at drawing these bell curves, am I? But we're not here to judge, we're here to learn. Okay, so 3.5, 4.1, 4.7, 5.3, 1, 2, 3, dot, dot, dot. Okay, 2.9, 2.3, 1.7, and then I'll throw my percentages in. And again, those percentages are not changing, right? So I'm sure you've got them memorized by now because you've seen me write them down so much. Okay, so it's saying we want to know, okay, so if during the course of a season you catch 135 northern pike, How many of these are likely to have a mass that is more than 4.7? More than 4.7 means I'd have to add up those two regions. So the first thing, okay, 2.35 plus 0.15 equals 25%. So I know 2.5% of the fish are supposed to be like that. So if I caught 135, I'd multiply that by 2.5%. Now remember, when you're multiplying by percent, you have to turn that into a decimal. So it's going to look kind of funny, but 2% is 0.02. And then I have to throw a 5 on the end for the 2.5%. And I'd get 3.375 fishies would be kind of fit that requirement. Well, we know that that's not how fish work. There's whole fish. So we'll say we'll round and see it's 3.3. We're going to round to just 3 fish. So there should be approximately 3 fish that would be like that. Okay, so let's keep moving here. Let's pick a new color, green. How many, if I catch 135, how many should be more than 5.3? Well, 5.3 is right here, so it's really just the 0.15%. So I'd go 135 times 0. So this is less than a percent. So I have to go 0.0015. Okay. If I times that 0.0015 by 100, I get back to 0.15. All right, so what does that equal? So that'd be 0.2025. Now, if I was to round that, I would say that round to 0. So I wouldn't expect any of my fish to actually be more than 5.3. I've used red. I've used green. Yellow's kind of, actually, let's go silver, people. I want to go silver. 2.9 right here. 5.3 is right here. So I'd have to add up all these regions here. Oh, sorry, not that final one. So I'd be adding up these ones right here, everything in between those end marks. So I'd get 34 plus 34 plus 13.5 plus 2.35. And that would work out to 84%. So I'd go 135 times 0.84. So really 84%, that's a big chunk. So it's going to be a lot of fish here. What do I get? I get 113.4. So approximately, just with rounding, 113 fish would be in that weight range. Okay, so remember, if your mode, median, and mean are all the same, then it's normally distributed. If it's normally distributed, we can draw one of these bell curves. The percentages don't change. The numbers are based off the mean and standard deviation. And then, yeah, you can do some of the things we did here, where you can predict a percentage of things that should fall between two maybe certain values, or if you know the percentages, then you can actually make predictions on how many actual things you would catch. Like this is fish, how many fish we would catch that would be within these requirements. So I hope that made sense. If it didn't, make sure you get talking to me or your teacher. Otherwise, have a great night.